Use Google Sheets to compare dichotomous outcomes between two groups. We're going to analyze a 2x2 contingency table very efficiently. So we could use SPSS, as we have in two other videos, to come up with my odds ratio, relative risk, and risk difference. As you can see, in those videos it involves quite a few clicks and a few unnecessary tables that we don't really care about. In this video, what we're going to do is take that 2x2 table and simply plug it into a calculator. So let's go back to our SPSS output. This is again using the indomethacin simplified dataset from this week's data. And in the output, it gives us this nice little cross tabulation where we get the proportion, or sorry, the number of bad outcomes and good outcomes across my two different groups. What I can do is take these numbers and plug them into my calculator. So if we go to this week's page and we scroll on down, there are some video links there. There's of course a checklist made for you, the practice data sets you can access. In this case, I'm going to use the 2x2 calculator. When you click that, it'll ask you to make a copy so that you don't go messing up the original, and you can all have your own to have and to hold. I'm going to just edit the original. I don't want to copy. Okay, you can just click the blue button and make your own. I will duplicate this so I don't mess up the original. And if we zoom in a bit so we can read it, there's some instructions. I know how to use this, so I'm going to go ahead and do it. All right. I'll scoot this over so we can kind of see everything. And you can see it kind of tells you where you want to put things. So what's my bad outcome? I would say pancreatitis is a bad outcome. And not having pancreatitis would be the good outcome. By convention, we put the bad outcome on the left and the good outcome on the right. You could also write pancreatitis up here and say yes, no. That's totally fine too. In fact, probably looks a little bit better. My experimental group is the indomethacin group, and my control group is the placebo group. Now I just need to put in those values. So how many folks in the indomethacin group developed pancreatitis? If we take a look here, we see that it's 27. How many didn't? Scoot over, 268. How many folks in the placebo group developed pancreatitis? 52. And how many did not? 255. Once we put everything in, the calculator will finally be happy, and it will tell you all kinds of wonderful stuff. It'll give you the chi-squared. Hey, look at that. It's 8, just like it was in SPSS. And we get a p-value, and it's pretty darn close. We've got our event rate. How many folks develop pancreatitis in the indomethacin group? 9%. And how many folks develop pancreatitis in the placebo group? About double that, about 17%. Okay, and then we get our odds ratio. Hey, look, this matches the SPSS output. I've already rounded it, so that's why it looks slightly different, but hey, there we go. It's about 0.49. It's from about 0.3 to about 0.8. 1 is not in the confidence interval. We have a statistically significant difference in the proportion of pancreatitis in these two groups. The relative risk of pancreatitis, you can see here, is about 0.54. That means my indomethacin group has about half the risk of pancreatitis compared to the placebo group. And how do we get that? We divided 0.09 by 0.17, or we divided 9% by 17%, and that gives you your 54%. So they were half as likely to develop pancreatitis when they took indomethacin. This is a good thing. The risk difference is given right here, and look at that. We get the same confidence interval. We didn't have to do a billion other clicks. It's right there for you. And then we get this very handy but hard to interpret until you do it a couple of times statistic: number needed to treat. This is highly relevant in clinical research, and what this tells us is the number of patients that we would have to treat with indomethacin instead of placebo in order to prevent one additional case of pancreatitis. It's not the number of people we have to treat with indomethacin to help one person. It's to help one additional person. right? And that number is 13. Mathematically, how we get that is dividing 1 by my risk difference. So 1 divided by 0.08 rounds up to 13. And we get a confidence interval. In this case, we're not looking for 1 or 0. We're looking for infinity. It's not in there, so that's good. Right, my odds ratio, my relative risk, we're looking for 1 in the confidence interval. We don't see it. That's great. For risk difference, notice it's a difference, so we're looking for 0. It's not in it. And infinity is not in the number needed to treat. Great, so all of these agree. And of course, my chi-squared down here is telling me that I have a statistically significant difference. If I switch 13 people over from getting nothing to giving them indomethacin, I can expect 1 additional person to benefit or to not develop pancreatitis. Right? If we treat 13 people with placebo, it's not like all 13 people get pancreatitis. You know, based on the event rate of about 17%, I'd expect somewhere around 2 people to get pancreatitis. Right? That's close to 17% of 13. Given the event rate of 9% in the indomethacin group, out of those 13 people, only 1 person would develop pancreatitis. So in that case, I'm helping 12 people, which is 1 more than the 11 I would have helped in the placebo group. So this is a very handy statistic. And the outputs that we got from SPSS did not tell us this. They also required quite a few more clicks. But if you're into that kind of thing, then hey, you know what to do. And if none of this made sense, you also know what to do. Drop me a question in the questions box. At this point, you should be ready to handle those checkpoint questions. It should be incredibly straightforward. If you're struggling on any of those questions, ask sooner rather than later so I can help you out.